unfreeze the board. Okay, number 1. Start off with a nice easy one. Number 2 is in fact this one. There's an equation. I would like you to try and solve that. Just pause this while you do it. Number 3, there's a formula that some of you may recognise as one of the equations of motion. V squared equals u squared plus 2as. I'd like you to rearrange that formula for u so that it reads u equals something, or make u the subject. Again, I'll pause when you have a go. Okay, final question. Here's a cylinder. The diameter of the cylinder, and this is a typical symbol for the diameter, a circle with a slash through it, which you could think of as the symbol phi, the Greek letter phi, but that symbol often represents the diameter. L for the length. There are the values. So what's the formula for the volume of a cylinder? Plug the numbers in using the calculator to find the volume. Again, I'll pause here. Okay, number 1 was actually a bit of a trick question. Answer? 2. Plus or minus. Well done, Alex. Yeah, plus or minus. If we think back, what we have here is y equals the square root of 4. But if we think back to what y could have been, there's 2 possibilities. Y could have been plus 2, because 2 times 2 is 4, or minus 2, because minus 2 times minus 2 is still plus 4. So there's 2 possibilities. Whenever we find the square root of a number, there's always 2 possibilities, positive or negative. So whenever you use this, there's always 2 roots. Don't forget the negative. Often in an engineering scenario, we're only interested in the positive answer, but there are 2 roots, and it's not it's not outside the realms of possibility. You could use both roots. So well done. Number 2. Right, so just quickly expand. 10x minus 15 equals 6x plus 4. Collect like terms means subtract 6x from both sides. So that just leaves 4x this side minus 15 equals 4. Add 15 to both sides to get rid of the minus 15 on the left. 4x equals 19. Divide both sides by 4. X equals 19 over 4. I could leave it like that, or I could work it out on the calculator to an appropriate accuracy. So it's those steps which you hopefully are starting to get familiar with now. Playing around with the thing, and so that you get x on its own by doing something, but you must remember to do it to both sides. Similar idea in number 3. I've got to get u on its own, so I've got to undo the rest of what's on that right hand side. I've got to get rid of this, and I've got to get rid of the square somehow. I think about this as being, okay, on the right, what's happened to u? It's been squared, and then afterwards the 2as has been added. So the first thing to do is get rid of the 2as. Subtract 2as from both sides. V squared minus 2as equals u squared. So same idea as the equation, and then square root to get rid of the square. So u equals the square root of v squared minus 2as. And that would be a new formula now to find u. Last one, formula for the volume of a cylinder. It's the area of the end, pi r squared, times the length. Assuming the cross-sectional area is the same all the way through. So if I were to cut this anywhere, I'd have that cross-sectional area here. Then this is always true, that the volume is the area of the end times the length. So it's the area of the circle at the end, pi r squared times the length. So in other words, if this had been something like that, then I'd again found the area of the end and times that by the length. Always the case. Putting the numbers in, the volume is pi times r, which is 3.6, half of that is 1.8, times 10 to the minus 3 squared, times 4.5, times 10 to the 3. And that's exactly what I type into the calculator to get. Anybody come up with an answer? Others? No? Anyone? Do it now then. So we should get round about 4.58 times 10 to the minus 3 cubic meters to 3 significant figures. If you didn't do that, just try it now. In one hit on the calculator, see if it works. Correction on this last one. 45.8 times 10 to the minus 3.